Hello, how are we doing today? Good. All right, so we kind of introduced some of the stuff in the general session, and we're going to actually show you some things we didn't cover in the general session in here that are super cool because we have the time. So I'm Chris Wolf, I lead AI and Advanced Services for the Cloud Foundation division under Krish Prasad, and my colleague here, Dilpreet Bindra, probably needs no introduction. One of the very best engineering leaders I've ever worked with in my life. So really excited to be doing this session with Dilpreet. All right, let's dive in. Let's go ahead and get into really what's happening here. So we are showing some future capabilities. So this is just a disclaimer on this, just so you're aware. I mean, we are talking some futures in here, so no guarantees. That's about it there. This was covered in the general session. I'm not going to spend a lot of time here, but again, like our approach from the very beginning has been that our focus is really heavily on inferencing. You can certainly use our stack for fine-tuning and training AI models, and we have customers doing that. But we see this as the dominant workload, and our ability to be able to allow you to take models and AI services to really anywhere you're running one of our stacks has been a really powerful concept with customers, because they don't want to, a lot of folks, I'm sure some of you in here, you don't want to move your data out to clouds just to gain some of the AI benefits, or you really strongly prefer to have control. So just a recap here on Private AI Foundation with NVIDIA. We can spend a little bit of time on this, but what you see here is really the core capabilities, at least what you see in the slide, is a lot of the things that we had introduced last year. We shipped in May as a generally available product. Some of that real core value that you get in the platform are the deep learning VMs construct. So this is natively hooked into NVIDIA NGC, so you can get your tools, your frameworks preloaded in the container at the time it's instantiated. So just a lot of value just in terms of the speed that you can start to deliver AI services, set up developer workstations for AI and these types of things. If you're looking to do retrieval augmented generation, which is a fantastic use case, it's often where we ask people to start. You need a vector database, and we're giving you Postgres and pgvector fully supported. So that's also just going to help you down the journey there. And we're seeing great results. I'm going to show you some new technology a little bit later in the presentation that is how we're automating support. This wasn't covered in the general session. So last year we did talk about the concept of VCF Intelligent Assist. We've been building this thing. It's very far along, and we're going to preview it in here later. But that's a great example of a RAG app, and we're going to show you how that's going to really streamline product support for you going forward. You know, you get a lot of automation with Catalog Setup Wizard, and Dilpreet's going to demo that in a little bit. And we're also going to go a lot deeper into our GPU monitoring capabilities. Now, I won't spend a lot of time here because I'm assuming hoping at least a lot of you saw some of this in the general session. But it is important to just level set on why are people working with us. This is the fastest growing new product launch I've ever been associated with in my career. We've seen just tremendous demand for what we're doing because you can get the benefits of AI on your terms, using your data, maintaining privacy and control of that data. That matters to a lot of folks. The centralized ops, being able to have the same set of tools and processes for all of your VMs, containers, and AI services, all that helps to drive the total cost of ownership down. And as I touched on, and we're going to get much deeper into what all this looks like on the product side. So I only had a time in the keynote to touch on this, but resource sharing and everything that we've been building into DRS is really, and GPU availability, we're going to deep dive on it in here. That has been what's really set us apart. In transparency, I've met with organizations, they're heads of AI, and they've been operating AI stacks on bare metal for so long. My first reaction was, well, why are you even talking to me? Like, you guys seem to have it figured out. And then, you know, as we met a few times, they were like, well, actually, we don't have it figured out. Like, we really struggle with GPU management, resource management at scale. We're not utilizing our GPUs efficiently. We need a better way to do this, and we really like what you've been building into your product. Now, this is a slide, if we had time, because Dilpreet and I are showing you a bunch of demos and a lot of tech, so I could spend 20 minutes on this slide, but we don't have 20 minutes. So yes, exactly, you get to take the picture of this thing, because this one's pretty important. Because we've talked about a lot of parts, but I think it's important to level set so you can see how all of this is wired in together here. So you're seeing a lot of these new services that I introduced this morning. We're rolling those out as supervisor services, and that gives us a lot of agility on the engineering side in terms of how we can get to market more quickly and not have to do all of this like locked into the full VCF release timeframe. So that's going to really help us in terms of how all this goes. And again, things like model runtime, our data indexing and retrieval service, our agent builder service. Many of you are probably familiar with Data Services Manager. Using VM classes with vGPUs is such an incredible construct. It's going to, and the way to think about this, like he's not here, but Frank Denneman and I, we spent some time talking about this, is when you think about Frank is here. Awesome. All right, cool. So Frank is, probably needs no introduction. I mean, Frank is the whole construct around deep learning VMs. Frank invented that. I mean, so Frank's an amazing technologist. Happy to have him on my team. And the uber point though on VM classes, yes, I can start to prioritize like VMs running as a lower class for vGPUs where maybe I want to be able to gracefully shut them down. It's a concept we introduced this morning. We're going to go deep on it. However, this isn't just about GPUs anymore. If I'm thinking about VM classes for HA, I can really maximize all of my compute clusters now, right? By having different classes of services, you're going to have the ability to run your own spot instances now. So that's where it gets really fun. Okay, so I think this is helpful. Again, from the namespace construct, this is really how we expect your data scientists and developers to interact with these services. They're going to get their own namespace. That's where they're going to get to live. They're going to be able to build their AI agents. They're going to be able to do their own data indexing. They're going to use knowledge bases to do some of that segmentation where you can start to implement your own access controls as well. And again, Harbor as the model store, that's the bottom right. That's where, again, I think a lot of this is also coming together for you. And for us, we deliberately said it did not make sense to build a separate tool for AI governance. You should use Harbor for it. And if you're following other news out there, GitHub a couple weeks ago announced the exact same thing. So there's a lot of momentum towards this approach by people outside of us. Not going to go through this line by line, but this is like best case scenario to provision a LLM-based RAG app. And this is assuming you already have VCF. Without VCF, this is going to be much, much longer for you to do. And this is something that we're able to do in a matter of minutes using VCF automation with Private AI Foundation. And this is where I'm going to pass the baton to Dilpreet, and he's going to kind of walk you through it.
So as you can tell, we're trying to deliver dramatic simplicity and agility through Private AI. AI is difficult. It has a very large ecosystem, and we want to make it simple for you to be able to get your applications up and running quickly. So let me walk you through how this works in automation. So when you purchase Private AI, you have these built-in blueprints that you can make available to your developers or your data scientists or whoever's deploying this application, and you can have them click on the AI Kubernetes RAG app, and they will get a form. And as part of that form, they can go through and select how large they want it to be, how many control plane nodes, how many worker nodes. They can actually put in the Private AI key for NVIDIA to be able to pull in the NVIDIA software, and then they can put in their Docker username and password to be able to do that as well. But one of the key things here is that they can also select their favorite AI/ML tools, right? So that gets injected into the deployment. So if they're using PyTorch or some such, they can actually inject it in so they don't have to do that in a separate environment or create a template that they want to be able to use. This gets injected directly in. And so at the end of this, you get this RAG chat app with, I think there's like 44 objects that are deployed in this, but you see all of the details here, and it's available to you, and you can then go to and see it in your resources pane, but then you can see it in your chatbot. You can go to the link there, and you can get directly to your chatbot. And so you can interact directly with this thing and then augment it. And of course, you have all the day two actions that your IaaS services provide to you. So if you want to change the sizing of something, or if you want to make sure you expand it or contract it, you can do that inside the automation pane. So this is dramatically simplifying your AI deployment scenario. Chris, you want to cover this?
Oh yeah. So there's a little bit more detail on this than we covered in the general session, so you can see the full picture here. So this is our latest MLPerf benchmarks. So again, you know, the meta point here is I can use vGPU, NVIDIA vGPU, and I'm not going to compromise performance really whatsoever here. So the left side is the offline scenario. So this is simulating more batch processing types of workloads. And then the right side, this is called the server scenario. This is more randomization. So think about more random type of inference requests. That's what you're going to see here in terms of these results. So what you're seeing is, you know, that batch processing is we absolutely shine here. On the right side, you see a couple of dips here, but still, when I've talked to customers and say, look, if I can virtualize and I can share GPUs and my performance tax is 2%, will you do it? The answer is almost always yes. And if you don't want to do that, you don't have to. Like, you could still use pass-through. It's fine. You know, it doesn't matter to us. You know, you all know the trade-offs of, you know, vGPU versus pass-through, but it's still the option for you. But again, this is eight H100s on a single node, and we're just, you know, crushing the heck out of it and doing really well. Mention a little bit, we have some additional ecosystem partnerships that we're going to be sharing. Dilpreet's going to share news of what we're doing with Intel just a little bit later in this session as well. And this is our current state, and the important point here is we're not out to collect logos. If we have a partner on this slide, we're doing something intentional with them. You know, we don't want to, you know, overwhelm you with 100 different partners. We want to be very precise in who we're trying to bring into accounts with us, and that's what you're seeing here. If there's some AI ISVs that you're saying, you know what, why aren't they on here? Talk to us. You know, come up to us after the session. You can reach out to us on social media or whatever works for you. But you know, would love to hear from you and get some of your feedback there too. Okay, so this should help you to also kind of level set in terms of where are we going. So we like to organize this ourselves into really like, what are your IaaS level services you need for AI? And then what are the core infrastructure services we need to develop as well? So on the IaaS side, this is things like indexing, retrieval, model gallery, agent builder. We're doing an AI API gateway to help you with things like token rate limiting as well for your AI applications. Providing model and data confidentiality, intelligent workload placement, understanding concepts like if a model is this size and this many parameters, what is the expected capacity? And then high availability, which we're going to go really deep into. And the last thing on the right, we're going to demo this. This is the first time we've ever demoed this technology, is VCF Intelligent Assist. We're going to show you how we're doing proactive support, and I'm going to go over the expected timeline. So we're doing this as a tech preview. It's not far away from something that you'll be able to enjoy in the product as well. Okay, now I'm going to turn it over to Dilpreet to cover the infrastructure services.
So let's see what's going on underneath. You know, as we go build into the future, what we're trying to build into your infrastructure as we move forward. So Chris already showed this slide, so I'll go past this. So vGPU reservation. If you have, you know, your catalog item that I showed earlier, and you have n number of these catalog items, let's say it's an AI workstation or AI RAG cluster, each one of those requires a different amount of capacity from your GPU. So each one of them may have competing priorities against the GPUs that you have. And so, and the GPUs are vastly different than CPUs. We can overcommit CPUs. But GPUs, you can't overcommit. You actually have the memory is used as a fundamental communication with the device. And so you need to make sure you slot the memory, right? You can't overcommit that resource. And so if we look at an example, and you know, if we place three AI workstation workloads, and you have these three GPUs that you can place them against, and they slot in, and you have additional slots that are available for additional 40 gig workloads. Let's say then somebody comes around and wants to deploy a Triton inference server. Well, that server requires 80 gigabytes. Now, none of those GPUs have sufficient capacity for that Triton inferencing workload. So it's completely accident if you can actually place your workload or not, right? You will not guarantee that workload can be placed. So as we go into the future, you know, you have, as you build out your cloud, you're going to intentionally pick how many of certain sizes that you're going to slot in for your GPUs. So you're going to say, I have a certain amount of these inferencing workloads that are going to take 80 gigabytes. And I have a certain amount of these AI workstation users, and I'm going to slot in a certain amount of those workloads, right? So you build out those slots, and when you have that AI workstation workload show up, they slot into the 40 gigabyte profiles that you already created. And then when that inferencing server comes back in, it gets provisioned into the correct slot for it. And how many of these slots you'll pick is up to you, but you're reserving capacity for those types of workloads, so you're guaranteed those workloads will have capacity in the GPUs. So let's talk high availability. Chris already talked about this earlier today, right? And if you go through and you provision those workloads we talked about earlier, and you want to make sure you have high availability, well, you have to then have a reserved GPU instance that you can use to be able to fail over a VM when it fails over from one of the host failures. So that's an extremely expensive resource that you're keeping idle so that you can actually do failover. And so instead of doing it that way, let's say we had a concept of a preemptible VM, meaning that a VM that is, can be destroyed when necessary if a failover event were to occur, but it uses the capacity you have in your GPU, and you don't waste any of your idle capacity waiting for that HA event to happen. So when you have that host failure, instead of using up idle capacity, now you kill that preemptible workload, and you go and restart your more important workload on that GPU. And this, clearly, as Chris pointed out previously, this has broad applications. GPU was just what steered us in this direction. You can think of this as a new way of doing overall resource reservation for HA. So let's look at it in real world. So you have these two applications, AI Workstation and RAG Chat App. One of them is preemptible, the AI Workstation. Your RAG Chat App is not preemptible. It's the one that you want to be highly available. You have a situation where host failure occurs. Quickly, it determines that RAG Chat App needs to be restarted onto a new machine. And it says, well, I need to go and kill this AI Workstation preemptible VM so that I can go and start that RAG Chat App. And then it goes ahead and after killing that workload, it starts the RAG Chat App. And so if you look over here, when the user looks at it in the automation screen, they say, hey, we recovered from an infrastructure failure for your workload. And the user that has the AI Workstation gets informed that their VM was powered off because of a failure event that occurred. So this is both between our resource management and our HA, you can see how we're dramatically trying to leverage the value we brought to you for CPUs into GPUs, right? So just segueing a little bit, today we're also announcing the VMware Private AI with Intel. And so this is a partnership that we've been working on for a while, and with Gaudi 2, we fully support Gaudi 2, and we have reference architectures associated with that coming out soon. Okay, back to Chris.
Whoa, that was dramatic. Sorry for that. All right. Microphone is still working okay? All right, cool. Okay, so before we get to the end, because we're going to have some Q&A and some time even for some offline chatter, I noticed that there's a few other Broadcom celebrities kind of hidden in plain sight. So just want to point out some other people you'll want to talk to after the session. So I mentioned Frank Denneman here. He's our chief technologist for AI, works for me. Also, Yu Wang is sitting right back here. Yu leads product management for Private AI Foundation with NVIDIA. So if you have any questions or product feedback specific to that solution, please go up and introduce yourself to Yu as well. So I'm glad that she's able to join us too. Anybody else I'm missing here that I haven't spotted? All right, cool. Okay, so next thing we're going to cover is our AI ML IaaS services, and again, just going a little bit deeper here and showing you a couple of demos in terms of what's happening in this space. So these are the areas, again, that we're going to cover that we introduce in terms of the future capabilities space. And where I'm going to start is with VCF Intelligent Assist. So last year at Explorer, we introduced this concept, and for us, we think it's really important to lead with the term Intelligent Assist, because our opinion is that AI is a tool that helps the human. It's not the tool that's replacing the human. It's helping the human to make better decisions and make decisions faster, and that's where we're really focused on. And now, before I show the demo, I just want to give you a little bit of background. So we've been working on driving this technology forward, and the expectation has been that we're testing it with our internal customer support organization first, and making sure that we have really good data, we're getting really good scores, and the model we're using is tuned extremely well. Then we're taking this to our distribution partners that are offering level 1 and level 2 product support. We're going to get some feedback from them. Assuming that goes well, which we expect it really will, then we're going to integrate this into product. So you'll expect the plugin from us, and that's how you're going to get to interact yourself directly. Now, what we've been able to do using an open source model is achieve really incredible results in terms of accuracy. We're in the high 70s right now. We're going to get much higher than that, because right now the last piece that we need is some of our actual product support data. We're indexing our Confluence pages, all of our internal engineering Confluence pages, our KV articles, PDFs, all of our product documentation. So that's all covered. So now when you have support issues, you don't have to just start at William Lamb's blog. You can go and use this tool that's right in product. So we think that's going to be a nice help to you. So let me show you now in the demo in terms of how this is looking so far. And again, you're going to see the in-product experience coming from us soon. So you're just getting a prompt here. How can I help you? We're asking about some vSAN cluster management, vMotion vSAN. Can they use the same uplinks? Is that something that's a supported configuration? So now you're seeing the output from the model, and just importantly, you're also seeing the sources. We're always providing that prompt that we want you to, we want the human to verify before making that final decision. But this is an actual something that was used by one of our customer support engineers. They put this into the tool. They ranked it very high, and that's why we're showing this one in the demo. But this is real product right now. There's nothing make-believe about this. We have lots of folks using this tool internally, and it's going really well. So we're going to continue to iterate there, but I thought that's something that all of you as customers would be pretty excited about in terms of where this can go. If there's certain use cases or certain ways you'd like to see it in product, that's where you could talk to us, you could talk to you to make sure that we're hearing your feedback in terms of what makes the most sense. All right, cool. All right, so next up. Only had time this morning in the general session to kind of gloss over this, but I think it's important to see our perspective on what that model consumption journey looks like, and also just provide a little bit more detail into how all of this is working. So our expectation is you're going to have some different model repos. We're listing a couple here. Could be custom, could be Hugging Face, could be NVIDIA and GC. Doesn't really matter to us. Then you're going into your deep learning VM namespace. I want to be able to make sure that I'm scanning, approving any models that I want to then move into something that I would share and publish and put into production. Harbor's OCI compliant registry. We have native support for NVIDIA NGC. You can use the Hugging Face CLI as well. And for your model runtime, we're using an OpenAI compatible API. So even if you're starting services in OpenAI, you want to run them on-prem on our stack, you're not going to really have any challenges from a migration perspective. That all works. And you get the same thing with the NVIDIA APIs as well. So they've done a lot of investment there too. So that's how the model runtime is going to work. And then really what we want to be able to do is interact with the data indexing and retrieval service that we built, as well as any agents or custom agents that you're looking to build as well. So we're giving you all of these tools to get started quickly, be able to realize very quick time to value for your AI applications. And again, for you, it could be third-party tools or whatever. That's part of our ecosystem in terms of making sure that we integrate with the tools that you prefer. Now, I didn't spend a lot of time initially on use cases, but just to double-click on the customer support use case, we think this is probably, and we see this from a lot of our early adopters, this has been really one of the key areas where the first movers have gone. And the reason for that is your public models are only going to get you so far with customer support because you have a lot of private data that you want to keep control of. And this is where you can realize really good results. And some of the ahas we've had running this service internally is, first, like the flexibility that like our Private AI Foundation platform gives you really matters. For our customer support service, we have changed the foundation model 3 times in the last 9 months. Our data scientists are doing A/B testing. They're finding better inference results, better accuracy, and we're flipping things around. And if you're curious, we're using Mixtral 8x7 as the current foundation model. We're getting fantastic results from it, and we're gonna stay on that path until we see better results from something else. Have you tried Llama 3? Yes, we have. This is where we're at right now, and this is the current path. But again, if things change, we have the agility to very quickly improve that. So that's where that's working. Again, that's a great place, we think, for you to start if you're trying to do that first type of POC and prove out the use case, and then go from there. Okay, so this was introduced, and there's really 2 concepts here, and you're going to see both of these in the demo I'm going to show you in a couple of minutes. So the data indexing and retrieval service, there's really a couple parts to this. This is allowing you to very quickly index and prep from some of your common data sources that you would have internally. So we'll have several that we'll introduce with the initial product once it's GA, and there'll be more that we'll add based on your feedback. And then I can use knowledge bases that can really help to provide that repo for these local files that I'm uploading. And again, that allows individual data scientists to try to not just prep the data, but have nice groupings for how I want to actually start to feed that into the model as well. And what you'll see in the demo is through policy, you can do things like set a refresh interval as well, because that's important. I don't want to just index data once, right? Then my model is going to start to become out of date. I want to make sure that I have that current. Our internal use case, we scrape data once a day, just if you're aware. And that's just been a process. And until IT says we're using too much capacity and we can't do that, that's probably what we'll keep doing for the time being. Now, the Agent Builder service is super slick too. So this allows you, once we get that knowledge, that model configured and knowledge base set up, this is where now from that now I'm building that entire agent now that's going to be able to interact with all this and pull it together. Once we set that up and set those constraints with the Agent Builder service, then I can start to test and iterate on it, and then I'm ready to deploy it. That's basically the workflow. So next thing that we're going to cover here is going to be the demo of this so you can start to see it. So I'm starting in Harbor. You see some of the different models that we have stored here. Now from the model runtime, you can use VLLM, you can use the Triton inference server. Again, we have OpenAI compatibility here as well. We're specifying some of the configurations for the model. Again, I could change the YAML, I can do whatever I want with this, so all fully configurable on your end. And again, we're showing a UI here, but this is all API backed, so it's really whatever the developer or data scientist prefers is how they want to work with this, even native Kubernetes. So what you're seeing in MinIO object store here, you're seeing a couple of SharePoint data sources as well for data indexing and retrieval that we've connected to. What we'll be able to do now with the knowledge base is be able to link the data sources that we plan to use to that knowledge base. So that's what you're seeing here. We're gonna go ahead and take our MinIO object store, and we have some of the files that we're seeing in here. So you're seeing some hybrid cloud validated solutions and private cloud validated solutions from the object store being loaded into the knowledge base. So now we want to go ahead and run that indexing job. This is where you see we can do some configurations here as well. So what is the embedding model endpoint I plan to use? What is the chunk size? Where do I want to start to split that? So we're doing that at the sentence level here. And now we're just about ready to roll. So we have the knowledge base that's indexed successfully. We go over to back to agents here now, and we're going to work to create an agent. So now what we're going to do is we're naming the agent, we're going to add a description, and the instructions, what you're seeing is we're just using some natural language to describe the capability that we want the agent to provide. That's going to be the last part here. And then we're going to be off and running after this. So we're adding indexing and retrieval, we're selecting our knowledge base, create the agent, and then on the right side here, we can start to test and interact with the agent right away. So, hey, can you tell me what is a VMware validated solution? Sure can. So now that's coming up. Then next up, do we have a validated solution for private AI? And what's happening here is the model is saying no because it doesn't have any awareness of the data source. So what we're going to do now is we're going to go and add that data source in here. So you see that we're adding that to the MinIO object store. So now it's in there. And if we re-index, we ask the same question. Now you're going to see a different answer here. So yes, we do have it. And we're always showing the data reference. So you can see this is what's referenced. The metadata is letting you know that there's a URL for it. And voila, here we are. We can go to that VMware validated solution. And if you haven't seen it, if you're interested in private AI, I would strongly encourage you to go and check this out. This document is extremely comprehensive. It's over 100 pages, really all the technical detail that you're looking for to be able to stand up the solution. So the good news is Dilpreet and I were planning this session out, trying to leave around 15 minutes for Q&A. So we figured folks would have some questions. Do we have mic runners? No? All right, we're doing this old school. So speak loud and we will repeat your question. How's that? So that's kind of where things are at. But hopefully you're excited about all of the capabilities we're bringing in to the platform to run AI services. Folks have questions? We have one up front here.
So if you want to build a similar KV-based, canonic-based one, do we have a way just to tap into the VMware KVs cloud or others?
You can use that with a data collector. You'd be able to if you were to build your own, you can do that. Like a popular open source community around data collection is Llama Index. You're going to see web data collectors, all sorts of different types of data sources. So you can use a web collector and go and do that and do the scraping. Yeah. Other questions?
Right there.
Right here.
The local workstation, is that adaptable for specific authentication and so on, if there's certain organizational specifics?
Yeah, we've been asking, it's actually something that we were asking our CTAB is, what are the custom auth providers you need us to support? So can you tell us what your requirement is exactly?
I was thinking more of marketing and if there's specific demands on it from the company itself that on the VM.
We're gonna support whatever you already have in VCF. There's no constraints on Private AI Foundation. Anything?
On the template itself, whatever it uses.
Oh, we do have a mic runner. How's
Look at that. Which template? Sorry.
So the template that. So the template that is used for creating the VM or the RAG or whatever, for doing that, is that adaptable for specific organizational demands?
Yes, so it's based on automation, like VCF automation. Automation has a bunch of ways to add custom workflows, and you can even augment the blueprint that we ship to you as part of Private AI and add a bunch of different workflows into it to be able to do a set of things that your enterprise would require.
We've also done a lot of work to harden the RBAC in Harbor as well. That was an important requirement to us, and we have all that Harbor RBAC done. That'll be in the initial product we ship. Okay, question up front?
You said the reserved slots, right, to place the workload in an efficient manner. Is that the number of slots is configurable or is the size is configurable?
So both the size and the number of each size is configurable. So you're of course fixed on the amount of GPUs you have in your environment, and then you create these slots and you figure out, okay, N of these, N of those, N of those, and so that's how it gets laid out on your infrastructure.
When you have multiple combination, how does the placement work? Like if I have multiple slots and the sizes, do you have any preference on how the placement works, or how do I know? How does the placement works? If you can just tell me how the placement works, that would help me to answer some of my.
Yeah, so the placement is essentially, so a user asks for a VM of a particular class. Let's say it's the 40 gigabyte, AI workstation use case. And that VM then gets directly placed onto an available slot. Now, of course, other DRS rules apply, right? So it's going to find the right place for that workload to live from a CPU perspective as well, from a storage perspective as well, but it'll then just map to that available slot and take up that slot. It's done through vGPU profiles.
Okay, good questions. Any other questions? All right.
Hi, thanks for the talk today. I had a question about the point that you mentioned that you kind of went through 3 different models over the past 9 months and evaluated through A/B testing. Can you speak to what are the metrics that you measured on? How did that entire process go?
Yeah, what we do is we test with our internal customer support engineers, and we have them score the response on a scale of 1 to 5 in terms of the accuracy and value of the response. So that's how we've been iterating on understanding, is there ways that we can improve? We're always looking at latency improvements. Just like our customers, we only have so many GPUs, right, in our portfolio. So our GPU and our CPU capacity that we're using for AI services. So anything that we could do where we're seeing measurable differences in performance that we're monitoring, that would also factor in. It's really that type of criteria. And the challenge is, like, I think as all of you know, the velocity, even in just like, you have the commercial space, of course, but even within Hugging Face is just tremendous. And it's one of the things I'll tell you, he's not here, but one of our data scientists, like, we'd always argue about was like, I would say we need to have more prescriptive guidance, and he's like, well, it depends. And I'm like, I know it depends, because we're in IT, and it always depends, right? But AI is so unique that you really have to get in and test and look at the model output to decide where you're at. And then to that end, there is a phenomenal breakout session this week if you have time. It's led by Ramesh Radhakrishnan. Ramesh is on my team, and his team operates these services. So if you want to go deep on exactly how we've architected and how we're running these services internally, go to Ramesh's session. It'll definitely be worth your time. Question in the back?
What are the minimums on hardware requirements? If you wanted to start like a POC for private AI, the VCF architecture, obviously you have your management domain / workload domain kind of concepts. Can you do something smaller than that for the purpose of a POC to kind of get started?
Yeah, I think there's a consolidated architecture where you can actually have the management and workload domains together, and that.
Yeah, it's four nodes.
Yeah.
4 nodes, and it has to be in the VCF consolidated architecture. It has to be a management workload domain.
Yes.
Okay.
Yeah, that's the easiest way. That's least amount of resources to get a POC going.
And if you have some A100s or H100s around that you can use, great. A lot of our customers, if they're just trying to demonstrate the POC, they'll just take some of the A100s that they've had and then rack those and then start from there.
Perfect. Yeah, thank you.
Anything else? One more in the front?
Do you require MIG being in the GPU select in order to get GRS sharing the GPUs?
Both MIG and time slicing are supported.
Okay.
Other questions? Thank you, guys.
Fantastic. Great questions. Thanks for coming.
Thank you.